Welcome, my name is Gary Conley. I'm a researcher at the Voinovich School of Leadership and Public Affairs at Ohio University in Athens, Ohio. I'll be presenting today on a portion of the project that we completed for the Department of Energy ports facility in Piketon, Ohio. The portion of the project that we completed was the Habitat Resource Inventory, which essentially is characterizing habitats that existed within the study area on the ports reservation and adjacent property owners within 1 mile of perimeter road. The study was completed over 2 summers of 2011 and 2012. You can see the study area here, which included the entire reservation outside of perimeter road, and the adjacent property owners, again, within 1 mile of perimeter road. So we begin by asking, what is a habitat? In terms of characterizing the habitats that exist at the ports facility, we decided to use our own characterization and not use the Anderson characterization, which in this case was a little too coarse for this fine of a characterization on site. The habitat is described by the physical environment and the biotic resources that are available for wildlife, and the ecological setting, which consists of the patchwork mosaic in our disturbed landscapes, particularly throughout the Midwest. We have quite a complex composition across the landscape. And by describing the ecosystem services and the functionality of those ecosystems. On top of that, adding complexity to the ecological setting is the disturbance legacy, which oftentimes results in the patchwork mosaic, and considering the climatic climax vegetation, which may or may not exist on site, may or may not exist anywhere in the Midwest at this point. But it is an idea of where our ecosystems are trending toward in order to reach a stability. So we characterized the ecosystems mostly using GIS. We used existing data to comprehensively characterize the regional physical, climatic, and biogeochemical setting. All this can be done with the data that was available beforehand, remotely analyzing the site and the potential habitats that might exist there. This provides a basis for understanding, analyzing, and evaluating ecosystem qualities. It allows for collection and storage of quality spatial data to inform decision making. GIS provides a template for continuing to add data and to query that data in the future to ask specific questions of the data. Some of the supporting data that we used to perform our initial remote analysis was aerial imagery and remote sensing resources such as LiDAR products, which is light detection and ranging, taken from aircraft down onto the site. It essentially sends a laser down and it strikes the multiple surfaces that we have at the surface, such as the ground level or the treetops. And by doing that, we can capture the canopy height of the forests. So we can easily detect where no vegetation exists, where low-level shrubby vegetation exists, as well as mature canopy. We also use a digital elevation model, or the DEM, one of the most widely used data resources in GIS. It helps us to decide the slopes, the hillshade, and the contours of the entire site. We also used the regional resources that are available from the state of Ohio and other sources. We begin by looking at what ecoregion the study area lies in. In this case, it's the Knobs Lower Scioto Dissected Plateau, which is part of the Allegheny Plateau. That gives us a foundation for deciding what we might expect to find. Here's the digital elevation model. We can see that the area, the study area, lies within a very dissected area, but also has influences from the last glacial episodes. You can see remnants of the former Taze River. Again, there's no river here now, but there once was a very deep river. In fact, the river is buried by as much as 700 feet of glacial till. That river once flowed north and northwest through Ohio, but was dammed by the successive ice sheets, flooding most of southern Ohio, causing the water levels to rise and spill over low divides between watersheds, and began redividing and reconfiguring the whole landscape of southern Ohio. In this case, now the rivers do flow south along the Scioto River channel into the Ohio. The dominant bedrock geology in this region is fairly diverse as well. We see three primary geologic ages represented, from the Mississippian in the east and the Devonian to the west. The dominant surface geology, again, is influenced greatly by the previous glacial episodes. You see the unglaciated, dissected hills surrounding ports, but it does lie within one of the old ancient river channels. This was actually a tributary to the Taze River called the Portsmouth River, which flowed north right through the site. And then again, the Scioto River is just to the west of the reservation. And we can see remnants of the glacial tills that were left behind by the numerous successive glacial sheets that entered southern Ohio. We can see these little terraces that were left behind over different time periods. Again, this all adds to the physical environment and the biogeochemical setting in which we might find different habitats existing. This slide shows the thickness of the drift left behind by the glaciers. You can see that ancient Taze River Valley was filled, again, with as much as 700 feet of drift thickness. And you can see that underneath a large portion of the reservation and the study area, there is a considerable amount of till there as well, which includes some very thick clay layers, which is one of the advantages to having chosen this site when they did. But on top of that physical setting, we have the engine that drives our ecosystems, and that's the climate. There's just one slide showing one factor of the climate system, which is annual precipitation. This was precipitation for 2012. And you see this would be quite variable year to year. This would also give us some idea of what we might expect to find within each habitat. On a dry year, drier species might tend to dominate. On a wetter year, wetter species might tend to dominate. So the aerial imagery that we used, you can see here we've zoomed into a portion of the northwest part of the reservation, just as an example, to show you what our aerial imagery might look like and how it's dissected. And you begin to see that patchwork mosaic. You see that we begin to see pieces of ecosystems intact, and we also see areas that show considerable disturbance. The green dots that you see are our actual study sites in which we took measurements of the vegetation. We'll talk more about the methodology here in just a moment. So we begin to do some surface analysis to determine where the natural stream channels would lie, where the natural divides between each of those watersheds might lie, and to decide where the steeper slopes, the gentler slopes, north-facing, south-facing aspects might lie. This begins to give us a background for choosing where we might set our sample sites, because we do want to capture a diversity of the habitats that are on site. So we also want to choose a diversity of physical settings. So again, here's the digital elevation model. And the same area of the Ports Reservation looks considerably different than the aerial photograph. But here you can see more clearly the elevation changes, where the steeper slopes might lie, flatter ridge tops, wide riparian areas in the valley bottoms. And we also even see some of the disturbed areas. You can see the railroad cut through the stream channel there. To the far right is one of the landfills You see it seems very, very ordinary in shape, very intentional. It absolutely was. So again, we use this information to explore our slopes, aspects, and then we begin to lay on the other layers, such as the LiDAR returns, first returns on the left and last returns on the right. The first returns are going to be the light that has hit the top of the canopy and returned to the aircraft before the light that has hit the ground surface. So in taking a measurement of the difference in time between the first return and the last return, you can actually calculate the canopy height. Now there are opportunities where the light will hit the top of a telephone pole or something, so we'll get a false reading, but oftentimes you can see those pretty clearly. But here we can see that the area around the landfill is quite devoid of any vegetation. The first returns and last returns are pretty much the same. But when you look to the upper left, you can see that we have a much coarser texture. We have a lot more first returns, and you can see that the canopy height there is much more than area that didn't have any canopy at all. In fact, that's quite a nice forest in that area. Here's a sample of the LiDAR. This is how it's captured. The airplane flies over, analyzes the surface with the laser, and the image to the right is a 3D image that we generated using that LiDAR data. You get a very good representation of the canopy, as if you were almost flying over it with infrared glasses yourself. Now, the DEM is laid under this image, so you can see the blue areas are the stream valleys, and the red areas are the ridge tops. And you can see some wooded ridge tops and also some wooded valleys. Now, field methods and observations. So using that baseline analysis, that remote analysis that we did, we chose 150 sampling locations in hopes to capture a diversity of habitats that exist on site. This was our sampling plan. Once we arrive on site, we establish 10-meter radius circular plots to do vegetation analysis. We set up one point in the center of our plot, drive a stake, take a GPS reading of that particular stake, and then we use a forester's prism to walk the perimeter and set up flags around the 10-meter radius perimeter. You can see a sample of one of our very first plots in the bottomland hardwood forest area, in the same area taken from the samples that we were looking at just a moment ago. You can see this is one of our field technicians using the forester's prism. I'll explain that in just a moment. The forester's prism is traditionally used by foresters to cruise the forest and look for harvestable timber. What it does is it places a 12-inch offset at 10 meters out. So if they're looking for 12-inch trees, they'll use the forester's prism horizontally, and any trees that are offset more than 12 inches, then that's a harvestable tree. In this case, we actually use it in a vertical sense, and we overlap the tape on our center post. You can see the red and the blue. And once those overlap, then we're actually 10 meters away from the center. So it's very quick and easy to get our 10-meter plots set up. The tape is obviously 12 inches apart. Within those plots, we measure all the trees and identify them to species. And we remove a couple of tree cores from a couple of the trees there on site to determine the average age of the stand. And then we will measure the shrubs. So we're trying to capture the canopy layer as well as the shrub layer. And we'll oftentimes take one quadrant or one quarter of the plot and measure all the shrubs the diameter at the base of those shrubs and identify them to species. Then we'll take a 1 meter hoop. Again, it's easier to replicate a circle than it is a square, so we use a 1 meter square hoop to measure all the herbaceous vegetation within the plot as well. And since there's 4 quarters to the plot, we will actually throw that hoop out 4 times to try to capture the full spectrum of vegetation we might encounter. We also took shallow soil samples down to about 12 inches to generally characterize the soil profile. A lot of the soils that we discovered on site were of windblown nature, which would most likely be remnant of the period in which the glaciers had dammed up the Tays, flooded southern Ohio, and then the water spilled over the low divides and the lake drained away, leaving dry lake sediments across the region. And of course, the winds would have blown these unvegetated sediments across the southern Ohio landscape, creating some fairly thick loess sediments. Some of the tools that we used, this is a DBH tape. That's diameter at breast height. That's the standard for measuring the diameter of a tree. We actually have tape measures that will tell us the diameter. Here you can see Rob setting out some of the flags. We used a lot of orange flags that helped us to guide our perimeter. It was very important to capture trees that were within the plot and not outside the plot. So flagging may seem like something trivial, but it's critically important to capturing consistent data. That data was captured on our data storage sheets. These were specifically designed for this project. The first section captured the tree species and the diameters of those trees. We also indicated whether the trees were living, dead, or morbid. Morbid meaning that they were beginning to die and showed signs of death. We also measured the shrubs, and you can see that we put the shrubs into categories based on the average diameter, up to 2 inches. We did also note any vines. We would measure those, the diameter of those at breast height when we could, and identify those to species as well. All the herbs were indicated on the back half of the sheet. The cover of each of those individual species, as well as the cover of the entire plot, was indicated on the sheet, and all the species were identified to species in the field when we could. If they couldn't be identified to species in the field, we would voucher those species, put them in a plastic bag, bring them back to the lab, and try to key them out the best we could. We also have a spot on the field sheet for the soil profile, but we also indicated habitat features that existed on site, such as holes in trees, standing snags. Dead trees make great habitat for a lot of different species of interest, particularly the Indiana brown bat. We also noted any other signs of wildlife that might be within the plot or visible from the plot. We saw lots of animals, and we also saw lots of signs of animals, including feathers and tracks and bones. Now, the field data was brought back to the office and entered into a digital database that mirrored the field sheets. So it was very easy to transfer the data into the digital database, and that database was then used to contribute to the GIS database that we have already created. So all this data was compiled in one place so that it would be queried together and analyzed for our specific purposes. So you can see we built the field data into a structure in which one plot would have multiple attributes associated with it, such as all the trees that might exist there, the size of all those trees, the number of shrubs and the species that comprise the shrub layer, all the herbaceous species and the cover that they might exhibit within each plot, as well as the soil profile and habitat features. All of that was built into our spatial database. Now again, we did survey not only the Ports Reservation, but a number of adjacent property owners. Habitats and ecosystems aren't restricted. They tend to interact with their surroundings. You have sources and sinks. Sources are high-quality areas that contribute propagules and young wildlife to the next plot, which might be a sink in which those species will either go in and make use of the resources that are there or be lost. So the field sampling results, we ultimately did 152 plots over the 2 field seasons, about 75 each year. Most of those on site, but we did get some very cooperative landowners and found some interesting ecosystems and habitats adjacent to the Ports Reservation. Again, data we collected in the plots, tree species, vines, shrubs, and saplings, herbs and grasses, shallow soil characterization, forest floor organic thickness and size of woody debris, one thing I hadn't mentioned. And we also confirmed slope aspect in the field using a Brunton compass. And any signs of disturbance or faunal signs or nests. Translating plant species occurrences and field data into categorized habitat coverage, we identified 32 cover classes. Some of those were anthropogenic classes, such as roadways and landfills. But as an ecologist, I see all of the land surface as either a sink or a source and contributing to or taking away from the quality and function of ecosystems. We did 239 tree cores, 122 wood cookies, in which we actually cut either small saplings or limbs to get some idea of the more recent growth habit of the woody vegetation on site. We did 361 other field points, such as any unique plants that we found, animal signs, or just field truthing points that we had remotely determined. We often found those occurrences in between the plots while we were actually traversing the site. And we also had about 100 plus pressed plant vouchers. Some of the species that we encountered that indicated quality habitats, the southern adder's tongue, it's not a rare or listed species. However, I would consider it an uncommon species. We did find this occurring quite frequently in the wooded riparian areas, which is an excellent sign for quality habitat and demonstrates a lack of disturbance for a considerable amount of time. Rattlesnake plantain, again, not a rare or listed species, but a species of fairly high quality, indicating quality upland habitats, and we did encounter this quite frequently. And this is a member of the orchid family. It can be found throughout southern Ohio in quality habitats. Some of the habitats that we did characterize were the palustrin habitats. Those would be associated with wetland type vegetation. Here you see a very excellent example of palustrin habitat at the south end of one of the large water bodies on site, as well as a monarch caterpillar feasting on some swamp milkweed, and some egg cases from a turtle nest along the Little Beaver Creek. Not exactly sure what species the turtle was, but we did see a number of different species on site. We also characterized some upland habitats, Here you see a Fowler's toad and box turtle, fairly frequently encountered in the more undisturbed upland habitats, as well as a small Houstonia. That was, I believe, Canada Houstonia. It was a first find for me. All indicators of quality upland habitats. We also encountered a lot of successional habitats and anthropogenic features on site. And again, ecologically I see quality habitats as well as not so quality habitats all contributing or taking away from the ecosystem functionality. So here you see, even in a roadside ditch, you can have salamanders reproducing. On some abandoned blacktop, here we have a dead shrew. And while that might seem a little morbid to us, it's a clear demonstration of how all of these land surfaces engage in the ecosystem functionality. So that shrew has come from a quality habitat, from a source area, into a not so quality habitat, and didn't make it out. So that would be considered a sink area, as far as I'm concerned. Resources go in and really don't come back out. We also see some lichens growing on, this is, I believe, some concrete at an old dairy barn. Nature will find a way over time to reclaim most of these anthropogenic features, but it does take some time. It takes considerable resources in order for some of those resources to make good with the available resources that are there. And that is essentially the function of succession. The rates of succession are determined by the rate of influx of propagules and wildlife, but also dependent on the resources that are there, the biotic resources that are available. Some of the uncommon plants that we encountered, I already mentioned the adder's tongue fern, but we also saw some tway blade and some elephant's foot. We also saw some very interesting prairie areas. That's a blazing star, and again the rattlesnake plantain and the netted chain fern, which was recently delisted in Ohio. But we also saw lots of non-native and invasive species, such as Japanese honeysuckle, the bush honeysuckle, multiflora rose, shrubby St. John's wort, and tree of heaven. While tree of heaven wasn't a big problem there yet, it had found its way into the ecosystem there along some of the disturbed edges and was becoming quite dominant very locally. Japanese honeysuckle was probably one of the more common species that we found throughout the area, as well as the shrubby St. John's wort, which is a native species. However, it can be quite weedy and seem to host most of the ticks that we found on site. Walking through shrubby St. John's wort in open fields was a sure ticket for getting ticks. We also saw, I see the Syriaca lespedeza as a frequently planted species for restoration and reclamation on site. So we did encounter that quite often, which is a pretty clear sign of recent disturbance. But it will hang on for a considerable amount of time, even as succession begins to overtake it. We saw a number of very big trees on site. Some areas have been really virtually left untouched for the last 50 or 60 years, and some of the hardwood stands show clear representation of that. Here we see one of the field assistants measuring a DBH on a 60-inch white oak. Now you notice that he's standing on the lower side of the tree and measuring the DBH at his breast height. So if you were standing above the tree, that would certainly not be at breast height. The standard is standing at the lowest point around the circumference of the tree and measuring DBH from that point. We also see some very large ash trees, which hopefully will remain. However, they're most likely doomed in the near future with the invasion of the emerald ash borer beetle. This is a very large 72-inch ingrown ash tree in which two ash trees have actually grown together. You can kind of see through them there. And then we also have areas of very tall canopy. While the trees themselves weren't huge in diameter, the canopy was very high up, more than 100 feet, and it was populated mostly with tulip poplars. While again we weren't focusing in on the wildlife, we did encounter a number of interesting species along the way, including some very interesting insects. The spiny oak slug moth, the great spangled fritillary. The fritillary is quite common. We also saw quite a bit of the large empty oak apple gall wasp. You can see the casing there. We see those quite often. You'll see those in oak hardwoods throughout southern Ohio. And there's the wasp himself. We didn't actually encounter that, the animal itself, but we did see the casings, the gall itself. Some of the other species I thought were very interesting was this bee mimic robber fly. It looks like a small bee, but is actually a fly. And the shieldback katydid nymph. You'd see it's a cricket-looking guy up there in the upper right-hand corner. We found several of those in very dry upland habitats in stands of native Virginia pine. Quite interesting habitats there. And Hercules beetle. He was already dead and desiccating when we found him, but still in excellent condition. Found that along a riparian zone. Some of the reptiles and amphibians that we saw on site, you can see at the very top a milk snake, and her belly's fairly full there. Recently had fed on something. I'm not sure what. That would have been nice to see what she ate. Perhaps it was a green frog. Just down the slope from that milk snake was this banded water snake and this green frog staring each other off. You can see they're actually in the same photograph along the side of a creek. They waited for a long time staring each other down. And then surprisingly, we saw the king snake. We actually saw several king snakes on site. It's a little north of their known range. And they were very healthy specimens, so I would consider that they're very likely breeding on site within the study area, which would be an indicator that perhaps their range is moving north, perhaps an indicator of climate change. The data analysis summary. So once we collected all of this data, we brought it back to the office and began to analyze it spatially in GIS and using simple statistics. We realized that we had captured almost 600 vascular plants in our field study. Several of those were listed species, state listed, not federally listed. The species list was the basis for the habitat evaluations, polygon classification, comparison of habitats, and wildlife habitat modeling and land planning recommendations that we made in our report. The native status of species was summarized. We found essentially 81% of our species were non-invasive natives for a total of 474 species. We did find a handful of invasive natives, again some of the ones that we talked about, the shrubby St. John's wort. Consisted of 33 species and about 6% of our sample. Planted or naturalized hybrids, we found 9 species, about 2% of our sample. Some of those were fairly widespread because they had established in successional areas. Non-invasive aliens, you might be wondering what some of those kind of species are, and daffodil would be a good example, although it can be invasive in some areas. We did not find it to be invasive at ports. We found 7 species that fit that category, about 1% of our sample. Invasive aliens, Of course, these would be the most troublesome of the species. About 11% of our sample, 65 species that we encountered were invasive aliens, and some were quite widespread, for a total of 588 species that we did sample. Each of these species has been assigned a coefficient of conservatism by the Ohio EPA and other researchers. The coefficient of conservatism is a value from 0 to 10 that indicates the quality of a habitat in which those species occur, not necessarily based on the rarity of those individual species, but the quality of the habitat that they only occur in. Now, a 0 would be given to those plants that have a wide range of ecological tolerances, specifically the invasive non-natives, as well as some of the invasive natives. A rating of a 1 to 2, again, these are generalized species. 3 to 5, intermediate quality. 6 to 8, quite high quality habitats, and 9 to 10 in only the highest quality habitats. And those would be species with a very narrow range of ecological tolerances. Of the species that we identified, 98 species had a rating of 0. About 17% of our sample represented very generalized habitat. 96 species were in the 1 to 2 rating, about 16% of our sample. 259 of our species were 3 to 5, about 44% of our sample, which is a clear indicator of advanced succession in a lot of the previously disturbed areas. We have 127 species in the 6 to 8 range, or 22% of our sample, which is a clear indication that there are some very good quality habitats on site. And we had 8 species that rated either a 9 or a 10, about 1% of our sample. And of course, those were found in very quality habitats. This region is known for a wide diversity of plant species. There's a lot of effort underway in southern Ohio to conserve large portions of the existing habitat, to conserve those more sensitive populations of plants. Southern Ohio tends to see the southern range of a lot of northern species and the northern range of a lot of southern species. So it's a very narrow area here in southern Ohio where many of those species overlap and can exist within the same habitat. If you go much further north or much further south, you wouldn't see an intermixing of those southern and northern species. So we have a fairly high probability of having a greater diversity of habitats and species. We also have some influence from the hypotherm that existed 5,000 to 8,000 years ago, in which conditions were quite dry here in Ohio, and the Great Plains tallgrass prairie species also migrated into the region. So we have some of those species represented as well. So you can see that Adams County has 62 listed species. Scioto County to the south has 45. Jackson County to the east, 59. Ross County with 47. And Highland County at 25. And Pike County, we have 32 known listed species within the county. And that's based on the 2010-2011 Ohio Department of Natural Resources listings. In analyzing all the spatial data that was collected and the field data, we began to do the delineation. We delineated habitats using all of that available data, bringing together the supporting GIS layers and the field data. Classification of features was based on species composition and the physical characteristics. And all land surfaces were considered to be some element of habitat. Again, we spoke of sources and sinks. And this was the habitat delineation results. You can see that the delineation included all of the reservation outside of Perimeter Road and the adjacent property owners. Whether they were surveyed or not, we felt that we captured enough samples within each of the different habitats to delineate those habitats that we hadn't visited on adjacent property owners. And this established a baseline for the habitats that exist on site. More detailed analysis would probably be required for some of the more sensitive species to determine the size of the populations and the conservation methods that could be used to preserve them or conserve them. We also see the disturbed areas in tan here that are under permanent anthropogenic control, but we also see lots of successional areas where disturbance has been in the past and are now revegetating, and lots of areas where the forest has existed throughout the entire period in which the reservation was on site. Forest cover by habitat, we saw that the bottomland hardwood forests tend to have the highest canopies, averaging almost 70 feet. The oak hickory forests tend to be about 60 feet. Of course, some of those upland oak habitats tend to have a little shorter canopy because the conditions are a little drier. And right on the top, you might have very stunted habitats in which the oak trees can only grow so tall. And a lot of times the species themselves will change. We found post oak and blackjack oak on site. You'll notice that the wetland or the palustrian habitats consisted of a fairly small portion of the overall habitat on site. We did have some planted pine areas that were quite extensive locally, but were fairly old. Many of them had been planted 40 or 50 years ago. But we also had, very surprisingly, a large number of native pine stands. Those ridgetop habitats were either of an oak composition or of a native pine or a mix, and those tended to be Virginia pines. And some of those were quite old and were also associated with a number of the higher quality or higher C of C value species. Of course, the mixed mesic forests were quite common on almost all the forested slopes, and sugar maple being the #1 species encountered in the woody species. So we begin to analyze this data and make some determination as to how the landscape is functioning as an ecosystem. And we can see here, this is dominance by non-native species. You see the larger red dots are areas where non-native species tend to dominate the vegetation plots. And for the most part, all of those areas are adjacent to some sort of a disturbance, particularly roadway corridors, adjacent to the landfill areas in which there's a frequency of disturbance that tends to favor the non-native species establishment. But then you see in some of the interior habitats, such as this area to the western part, the northwestern part of the study area, as well as some in around the pond over here on the northeast part, tend to have very low dominance by non-native species. So the interior habitats tend to exhibit the greatest degree of native species. And again, we were observing wildlife as we transect the site. These are a collection of observations that we made for wildlife. We observed amphibians, reptiles, birds, insects, and mammals on site, and a number of different either signs or sightings. And we can use those species that we measured in the field to determine any evidence of overbrowsing by deer. And you'll see a similar pattern as you saw in the dominance by non-native species, in that evidence of deer tend to be along those transportation corridors in areas that have a higher frequency of disturbance. And the interior habitats tend to have very low evidence of overbrowsing by deer. The evidence that we used was by species. Virginia tickseed and a couple other species tend to be evidence of deer browsing, because the deer won't feed on them and the seeds are transported oftentimes in the fur of the deer. Then we use all of this data collectively to do a habitat suitability index analysis. We ran these HSIs for several different species on site. And an HSI indicates where suitable habitat exists within the study area. It doesn't necessarily mean that those species are there, but if you were to go and seek them out, these would be the areas that you'd most likely encounter them. The HSI is a 0 to 1 rating, 1 being the most suitable and 0 being the least suitable. We've broken the range into 5 categories there to show you the dispersion of suitable habitats from low range to high range. And you can see that there are areas in which there's a fairly good chance of encountering quality timber rattlesnake habitat in the northwestern and some in the northeastern part of the reservation. We also ran an HSI for the wood thrush. Again, you can see some of that similar habitat area in the northwest and the northeast of the study area, and smaller portions in the scattered woodlots around the eastern edge and a little along the western edge. The northern bobwhite, again, it would require a little bit different habitat than the previous two. They prefer a little bit more open habitat. And you can see here in the southwest portion of the study area is very high quality habitat for bobwhite. And in fact, we did encounter a number of bobwhite while we were in the field in that area. And there is some existing habitat over on the eastern portion of the study area as well. The Henslow sparrow is a federally listed species. We ran HSI here looking for potential habitat, and we did find some very quality habitat just in the southern part of the study area, be outside the Ports Reservation, and minor pockets of habitat, suitable habitat throughout. And of course, one of great concern is the Indiana bat. The HSI has evolved over the last couple decades, and we used the most current method that's out there. And what we discovered was there was a considerable amount of suitable habitat for the Indiana bat. However, you'll notice there are dark lines along a lot of the transportation corridors and the power line corridors. It seems that the highest quality habitat is along those edges in which brooding habitat is available, as well as feeding habitat. And it's thought that the Indiana bats prefer to fly out into open areas to feed, but then do prefer the shelter of an open canopy forest. Now, in the very northeastern part of the reservation, you can see a detailed delineation of the habitats. This is a fairly disturbed area. We have a shooting range there in about the center of the screen. In the lower right of the screen, we see a highly disturbed area that's successional in that it's very shrubby. And you can see that that's sort of that brown area. And the little triangle-shaped area in the center at the top is a Barrow's pit, in which fill dirt was removed to cap some of the landfills, and was highly disturbed, but some interesting habitats had emerged there. And the green overall is a mix of the different forest habitats. The lighter green is the mesic forest. The middle green is the oak hickory forest, and the darker green is the native pine stands. These forests seem to be a bit isolated by the disturbances around it, and this actually is one of the candidate sites known as Study Area D for a disposal cell that is being built on site, and this is the area potentially affected by the construction of the on-site disposal cell. And you'll see to the right is a breakdown of the habitats that would be most affected by this disturbed area. About 68 acres of oak hickory forest, 51 acres of mixed mesic forest, 34 acres of native pine, and but the rest of it is much of it is successional or mowed and maintained areas with less than an acre of palustrine habitat being removed. I wanted to thank you for your attention today. If you'd like any more information about the project that we've completed here, you can please visit www.portsfuture.com. Again, my name is Gary Conley, and I want to thank you.